Welcome to this explainer, everyone. Today, we're unlocking the student's secret to faster learning. If you're someone who really needs to absorb and retain new information quickly, well, you're in the right place, because we're about to completely shift how you think about memorizing. We're going to break down the actual science-backed mechanics of rapid retention. And as you'll see, just tweaking your approach a tiny bit can absolutely change your whole relationship with studying.
So let's start with the scenario you probably know a little too well. You sit down to study, you read the exact same sentence, 5 times? It feels super familiar in the moment, you really feel like you're making progress, but then, why does the brain seemingly delete everything just 2 hours later? It's literally like the information never even existed. You put in all that effort, you read the text, and then the retention just vanishes, leaving you staring at a blank wall in total frustration.
Well, this brings us to a really crucial realization. Memory honestly has very little to do with raw intelligence. It's not about having an inherently good or bad brain. Biologically speaking, your brain is actually designed to forget almost everything. Just think about it from a survival perspective for a second. If you remembered every single detail of your day, every single license plate you saw on the street, every leaf that blew past you, it would completely overload you and destroy your ability to focus. Your brain is constantly asking itself, is this important enough to keep? And if it thinks the answer is no, the data just disappears. So forgetting isn't a flaw at all. It's a highly evolved built-in feature. The problem is, we so often treat our brains like a computer hard drive. We assume we can just passively input information, read a page, highlight a few lines, watch a long lecture, and just hit save. But in reality, learning is all about reconstruction. Your brain doesn't just store files in a neat little folder somewhere. It strengthens neural pathways through the actual act of retrieval. Passive input, like just rereading a chapter over and over, simply doesn't convince your brain that the information matters enough to hold on to it.
And that brings us to this truly fascinating concept in cognitive science known as active recall. It's basically the process of forcing your brain to retrieve information to build and strengthen those memory pathways. Your brain remembers information significantly faster when you force it to struggle correctly. So instead of reading a page and just moving on because the words feel familiar, the absolute most efficient learners will read a page, close their notes entirely, and literally force their brain to retrieve what they just looked at.
The really crucial takeaway here is that difficulty during recall is actually a sign your brain is adapting, not failing. That tiny, sometimes incredibly frustrating mental struggle to pull the information out of your head without looking, that is the exact mechanism that builds the memory pathway. The harder that recall feels in the moment, the stronger the memory becomes afterward. So even if you only remember, say, 20% of what you just read, testing yourself beats rereading every single time, hands down.
Now, your brain absolutely loves incomplete patterns and stories, but it really hates isolated random facts. Random information dies quickly, while connected information survives. If you try to memorize raw, isolated data, like that classic textbook line, ATP is the energy currency of the cell, your brain kind of treats it like robotic spam mail and tosses it straight into the trash. But when you create a connected hook, like comparing ATP to a battery pack for cellular work, your brain instantly finds meaning in it. Meaning creates memory hooks. So if you want to memorize faster, stop asking how to repeat things more and start asking how to connect them better.
Okay, so there's this shocking rule in cognitive science surrounding the number 24. Back in the late 19th century, a psychologist named Hermann Ebbinghaus discovered what we now call the forgetting curve. Researchers found that without review, your memory of newly learned information drops aggressively within the very first 24 hours. Meaning, if you study something today and simply never revisit it, your brain slaps a temporary information label on it and poof, it is gone. This is exactly why you might feel like you studied so much all week, but still blank out entirely during the actual exam.
So how do we fix this rapid forgetting? The answer lies in the spaced repetition framework. Memory requires spaced reinforcement over time, not one giant stress-fueled cramming session the night before. The trick is to review the information right before your brain is about to forget it. You learn the concept on day 1, do a quick review on day 2, again on day 4, day 7, and day 14. With each pass, the review takes less and less time, but the memory becomes incredibly resilient. It creates long-term retention with significantly less overall effort than panicked cramming.
You know, emotion is a literal memory superpower. It's exactly why you can vividly remember some highly embarrassing moment from 5 years ago in agonizing detail, but you can't remember yesterday's biology notes to save your life. Emotion tells the brain, hey, this matters. So you need to deliberately manufacture that intensity. Teach the concept dramatically to an empty room like you're delivering a TED Talk. Use urgency timers to create a thrilling little challenge.
Put on some strong focus music. Visualize your future success. Emotion increases attention, and attention increases encoding. Conversely, boredom literally destroys retention. A distracted, bored brain simply will not memorize deeply. That actually leads us to a highly effective technique called the blurting method. The process is super simple but really intense. Step 1, study a topic normally for about 20 to 30 minutes. Step 2, close absolutely everything. Then Step 3, take a blank sheet of paper and just write down everything you can possibly remember. Make it messy, make it incomplete, it really doesn't matter. Just force the retrieval. Once you're completely drained, Step 4 is to open your notes again, compare what you missed, and repeat the process. This brilliantly combines active recall, error correction, and deep encoding all at once. Because your brain notices its own mistakes so strongly, that corrected info is going to stick much faster the next time around.
But look, none of this works if your environment is working against you. You absolutely have to aggressively protect the first 25 minutes of your study time. No notifications, no multitasking. Why? Because of a crazy phenomenon called context-dependent learning. Your brain heavily attaches memory to context. If you constantly study while scrolling or with your phone buzzing every 3 minutes, you are quite literally teaching your brain distraction. Shallow attention creates shallow memory. If you want deep encoding and faster memorization, you absolutely have to eliminate those interruptions and create a clean environment.
Now let's move to something most of us drastically underestimate: sleep. Sleep is what actually finalizes memory formation, replays the important information, and physically transfers data into your long-term storage. You do not fully memorize a subject while you are studying. Your brain finalizes the process during deep sleep. This completely, 100%, debunks the myth of the heroic all-nighter. Staying up all night studying backfires because you are sacrificing the exact neurological process that stabilizes what you just learned. For the best retention, study that difficult material a few hours before bed, and then just let your brain do the heavy lifting while you rest. Let's look at an advanced trick called interleaving. Instead of blocking out 4 straight hours of math, which, let's be real, feels highly productive but often leads to diminishing returns, try breaking it up. Switching between, say, math, biology, and chemistry every 45 minutes forces your brain to constantly re-engage and ask, wait, what strategy do I use here? That extra mental effort of shifting gears drastically improves your long-term learning and cognitive flexibility, even if it feels a little slower and more challenging at first. So, taking all this into account, we really need to completely change how we track our progress. We have to stop measuring learning by the number of hours studied, the amount of pages highlighted, or the length of the lectures watched. Those are just vanity metrics. Instead, you should measure learning strictly by real, science-backed benchmarks of retention. Ask yourself, what can you recall purely from your head without your notes? What can you explain clearly to someone else? And what information actually survives in your brain after a 3-day gap?
This beautifully ties into our core thesis here. Real memory is not recognition, it is reconstruction. When you look at an open page of notes and say to yourself, oh yeah, I know this, that's just recognition. It's an incredibly common illusion of competence. True memory only happens when you construct the information from scratch, completely from inside your own mind. Once you start studying the way the brain actually learns, rather than fighting against its natural design, the entire process becomes so much more rewarding.
So, the big question is, are you ready to stop studying harder and start struggling correctly? You now have the exact mechanics: active recall, spaced repetition, the blurting method, interleaving. The science is incredibly clear on this. The next time you sit down to learn, don't just passively read. Challenge yourself, embrace that initial mental struggle, and watch how incredibly quickly your brain adapts. What else is your brain capable of if you just stop fighting its natural design? Thanks for joining me for this explainer, and I'll leave you to ponder that for your next study session.